Welcome back to the next of our recordings. Today we're going to deal with the Ziegler-Nichols open loop tuning method. Now, in the case of open loop, all that you need to remember is that my controller is going to be in manual. On the other video on closed loop tuning, you would have seen that the controller would have been in automatic. So we're going to do the open loop tuning method. Now, what's quite nice is that Ziegler-Nichols have gone and studied many different loops back in the late 30s, and they came up with a series of formulas that we can go and utilize. If you're just dealing with a P control or a level, you probably can just go and get away with that control for pressure. Then you only have to go and calculate the gain. If you're working with a faster process such as flow, then you want to do PI control, and in that case you need to calculate the gain and you need to calculate the integral value. If you're doing a full PID, such as a temperature or a pH or a conductivity, then you need to calculate the gain, the integral, and the derivative. Now, looking at those formulas, I will have to go and get a value of L, and L is going to be my dead time, and I will show you how to get that. We also need to get a value of N. N is going to be the percent per minute change of the process variable. And then we will also go and get the change in the output. Maybe I should go and put in the word delta in the front of output. The change in the output would then allow us to go and do that type of calculation. So let's go and do this. I'm going to go to my simulator and start it up, and it's busy starting up on my spare screen. And let's just go and select an appropriate model that we can go and use, bring it across so that you can see the screen, and that is it. Now, if you look at my screen, you can see that my process is in degrees Fahrenheit, 0 to 500, and I always like to go and work in percent. Great, the controller will be put in manual, and the whole idea is that we give it a step change. So I'm going to take my output to 20% and allow the process to self-regulate. If we go to the data monitor, you can see that my output is sitting at 20 and my process variable is at 32.5. There is the output, there is the process variable. Now I give it a step change, and you can change it as much as you want to. I always recommend that you change it just enough, more or less, in the place where you are doing the control. So I'm going to change my output to 50%, and let's go and have a look at what it is going to do on the process. So with an output of 50%, you can see that my process variable is probably going to go up to about 77.5. Great, that's it. So I'm going to pause the screen. And now we go and use the greatest Microsoft tool ever designed, which is going to be the snipping tool, and capture the screen. That's it. I'm going to go and capture the screen from there to there. And that looks great. We can now go and do our calculation. So I'm quickly going to go and get a blank page and paste the screen down, put it in the center so that you can see it. Now, in my classes, I would actually take everybody through this step by step. But in essence, what I want to do is first go and get the value of L, which is the dead time. And in the case of L, I would go and have a look at where the output has changed. You can see where the blue line went up, to where I'm going to get a notable response in the process variable, where I can start to see the red pen responding, and that's going to be about it over there. That's going to be my value of L. Now, my screen is giving me blocks from left to right of 5 minutes. So in this case, L would be the distance over there, and very thumbsuck, that L is probably going to be about 2 minutes. And L is going to go into multiple points in the formulae that have been given to us. Then I need to go and get the value N. Now, N is going to be in percent per minute, but in my calculations, for the fun of it, I'm going to change it to seconds. Now, N is very easy. What you're going to go and do is you will draw a line which matches the slope of the red pen as close as possible. No exact rocket science here, so just near enough is good enough. I'm just going to go put that on, and I must be a little bit out over there. Let's go and take it like that and see if that gets closer. That seems to be about as good a match as we can go and get. Right, the next thing is to then go and put any triangle together. Now, I can go and use a small triangle. Let's just go and show you this with a pen. I can go and use a small triangle as per that one over there, or I can go and try and use a bigger triangle as per that one over there. It's entirely up to you. So I'm going to try and make my triangle as big as possible. Let's go and take a line from there maybe across, and we can go and do the triangle down from there. That seems to be good enough. Okay. So what I need to do is I must get the percentage change of the triangle. This looks like 10, 20, 30, 40, 50, 60, 70. That's 80%. So there's going to be an 80% change in how many minutes? Let's go and have a look. 5, 10, 15. That looks like 20 minutes. Now, today, everything has worked out perfectly, but it could have been 83% over 23 minutes. That would be it. So we're going to go and use those values to calculate what we are going to get for the PID values. Now, again, don't work harder, work smarter. I've gone and created a spreadsheet, which will do all of this for me automatically. My output changed from 20 to 50%, which was a 30% change. And then the dead time, we calculated that value of L, which you would have gone and seen. I had a value of about 2. Now remember, we're working in seconds. So 2 minutes times 60 is going to give me a value of 120 seconds. We're going to put in a value of 120 over there. Now we get to that triangle of mine, that value of n that we're trying to calculate. And we said that n was going to change 80% in 20 minutes, by the way. That's not percent. That is going to be in minutes. So it's going to change 80% in 20 minutes. Go back to the spreadsheet. It's going to change 80% in 20 minutes. Now, 20 minutes in seconds is going to give me 20 times 60. And that gives me 1,200 seconds. You can work it out in seconds if you want to. Great. And there it is. We can either go and just take the p-value, or we can go and take the pi, or we can go and take the PID. I'm going to use the PID, and I'm just grabbing a piece of paper to go and write this down. It's giving me a value of 4.5, 4, and 1. So I go to my controller, and I put in the values of 4.5 and 4 and 1. And then all that we now need to do is to go and test the process. Put the controller in automatic, run the process, and let's have a look at the control that we can achieve. Again, Ziegler Nichols is a very aggressive tuning method. When it works well, which is 95% of the time. But if it does tend to oscillate because it's too aggressive, you might want to go and fine-tune the process. I've taken the set point up to about 75%, and as you can see, fantastic control that we are achieving. It's going to take it down to about 30%. And once again, the control is going to be fantastic. And I am very, very happy with those results. Super. Okay, so in a nutshell, that is what all of our open loop tuning is about. I have included my website at the bottom if you want to go and see a number of the different instrumentation and electrical courses that I do present. And there will be a lot more videos after this, so please do watch out for some of the more important concepts. Thank you so much, and I'll see you next time.